It's HYLN video time, and in today's video, we'll take a look on how long does it take to 3D print parts for the Carnot generator. Because whenever people ask HYLN, how long does it take to build a Carnot, he just kind of gracefully sidesteps the question.
We are still working through exact throughputs per machine. Now we have a good idea of it. We have built the cost models. We see it's economical in order to do it. The reason we're not giving an exact number is there are parameters that we can change, right? So as we're in the R&D phase, we're more running these machines on the conservative end. And then as we get into production, we'll continue to push those bounds.
So the first question is, how many 3D printed parts do you have to make per shaft of the Carnot generator?
As Josh mentioned, you really have four main components. Your linear motor, which is just coils and magnets, and then you have these three parts on the outside, which these are the parts made through additive manufacturing.
We have established that there are three parts. And as you look at this shaft of the Carnot generator, those three parts are mirrored on each side, and it looks like one of the components is missing off of the left-hand side, so we have to look at it at a different angle.
So the entire system, and if we kind of walk around here, from this location to this location, is fully hermetic.
The last part is on the very left-hand side on this video, so there are three 3D printed parts on either side of the shaft, giving you a total of 6.
Sealed, right? So what you're seeing here is each one of these shafts, you can see 4 of them located here next to me.
In its standard configuration, there are 4 shafts with 6 3D printed parts per shaft. 6 times 4 is 24 3D printed parts.
About 50 kilowatts of total output for a total package of 200 kilowatts, which we have here.
So what's involved in making a 3D printed part?
As you're making a part, like how many layers are actually in one of these
Yeah, it
parts?
depends on the size of the part, but we will normally have 5,000 or so layers at a thickness of 20 to 100 microns per layer.
5,000 layers, that's very good information to know. But when he says 5,000 or so layers, I can't quantify the or so part, so I'm going to have to assign that to a variable X.
Metal additive manufacturing is not that dissimilar, but the way it works is you lay down a bed of powder, a bed of metal that's in like a dust form.
The first step, from what I can see, is this light flash
To the layer below,
which takes approximately 1.42 seconds. And you have to take that and multiply that by 5,000, because there are 5,000 layers. And I'm assuming for each layer, that light is going to flash.
Once it's done with a layer, the part drops down a little and you lay down a new bed of powder to start that process over again. So
to push powder, it takes approximately 7.58 seconds. There's 5,000 layers, and that equates to about 10.5 hours of just that process of laying down powder. The last part is a welding video clip that is 4.4 seconds long, and unfortunately it doesn't show welding the entire layer, so there's another unknown. And I have to assign the unknowns to another variable, y. And of course, as you print each layer, that shape is going to gradually change over time. And I can't use that 4.4 seconds uniformly, but it's the best that I can do with the video that I can briefly see of this 3D printer working on a layer of making the Carnot.
And then a laser goes around and it actually zaps the metal, welds it.
If you had one machine and all that machine did is print components for the Carnot generator, and looking at that video, you have a light flash, a process of laying down powder, a partial video of the 3D printer welding parts, an unknown part, which I cannot see. You have a known total of 13.4 seconds of it doing that, and an unknown total of y. There are 5,000 layers, and there's an or so part. I'm just not going to include that in this part, just for like try to get a ballpark on what the minimum time would be to create a part for the generator. To print it for just one part, it would take, you're looking at about 18.6 hours. And for each shaft, there are 6 parts per shaft of the generator. And if the printer worked perfectly and generated 100% usable parts with 0 defects, you're looking at 4.65 days of this thing constantly running. And there's an unknown time component as well, because we don't know how long it takes to print the rest of that part. And we know that there are 4 shafts in the generator. So if we just had one machine running, I'd have to take 6 times 4 is 24. You're looking at about 18.6 days of constantly printing 30 parts. And I'm sure if Thomas sat down and he said that number, the stock price would go down.
And then from the design perspective, it's really only using, again, the material that you need. So you're not wasting time melting components that you don't need, but also using the energy effectively. We nest parts, or we sometimes have multiple parts print simultaneously, and that helps reduce the cost.
So one saving grace is that you can print parts simultaneously. So if you have 3 different types of parts that need to be printed and you had 3 machines, you can do a divide and conquer approach, which would give you, for the total known part that we know, of 1.55 days. But then you have to realize that there are 4 shafts, so you got to do 8. And that would give you a total of 6.2 days for a minimum time of printing the known parts. But then there's an unknown time component, and that would change to kind of this equation, which I can't solve for because I don't know how long it takes to print the whole entire thing. So if you had 3 machines and they all printed parts simultaneously, they ran without problems at all. You had people up during at multiple shifts, changing parts, cleaning things. Everything's all quality free. There's no defective parts. You can potentially crank out a 200 watt Carnot generator, just the 3D parts of it. That doesn't include assembly, or they have to hermetically seal it and put helium in there, and then put it in an enclosure with additional parts in it. And I'm sure that's more time, but at least you kind of get a baseline of what it would take to produce parts for a Carnot. So if you had 3 3D printer machines, you can potentially create a Carnot generator in slightly under a week. But realistically, it's going to take more time because there's an unknown component with how long does it take to print the rest of the layer, and for each second. So it'd be 5,000 divided by 86,400 times 6 for each second. It would add almost a third of a day. That's it for this video, and of course, thanks for watching.